And I'm very fortunate to have him as a teacher because he's showing me the way. He's pointing the way to become the same way, creator and joyful. Then there's another student on the other side of the room, bless her or him, who will say, this person is really arrogant. The other thing he talks about is his readers and his incredible problems that he's creating. And that person is going to remain a victim, not a victor, until the day comes and says to himself, reality is that I had the opportunity to learn from him, but I didn't. And it's better to start even a little bit later. You can see what we see depends in what kind of plane we're moving. Huh? Yes? So be careful how you perceive reality, because that will help you to become successful, huh? Yes? Huh? What's the answer? A. B. You didn't write anything down? How many people wrote something down? Let me see your hand. How many people did not write anything down? Let me see your hand. Come on, don't be shy. How many people did not write anything? You got to write something down. You cannot just look at the problem. Huh? Now you can do it. You should learn to do two things and three things at the same time. You think it's not possible? Everything is possible for someone who knows himself. There's people in history that they were doing 3, 4 things at the same time. Just like that. You're talking to somebody, they're writing, they're doing all kinds of things. Music, talking to somebody. Have you seen a person do 6, 7 things at the same time? If you want to see someone, come with me someday. I'll show you someone who does that. You can go and watch a person to do at the same time 6, 7 different things. Talking to the phone, somebody, talking on Skype, and do other 4 things at the same time, that they take intellectual capability. You do 7 things, 6, 7 things at the same time. Totally involved with all these 6, 7 things at the same time. Have you seen ever that? Yes. You did? Okay? If you want me to show such a person to you, come and I'll show it to that person to you. You will do like this. Huh? How can that be? Huh? Because we have infinite potential inside us. Each one of us can do it, actually. Sooner or later. You can do it sooner or later. So what's the... Now let's do it again. A, B, C, D, E. Not a good response. Why? Well, first of all, this problem has two parts, right? So you got to get both correct to be able to have the correct answer, right? So it's a little bit challenging. So let's see it. It's talking about what? The energy of an electron, of monoelectronic species. So when you have species that they are monoelectronic, yes, then we know from the lecture that the energy is given by what equation? Energy, when the electron is in the nth shell, right? 1, 2, 3, right? First quantum number, 1, 2, 3, is given by minus RH, the constant, right? Z squared, the atomic number, divided by the number n squared, which again, n stands for the number of the shell, right? 1, 2, 3. 1, 2, 3, farther away. Yes? Okay. I mean, what else are you going to use? You're talking about electronic speed, you're talking about energy of the electron, that's what you have to use. Okay? So now, it talks about 2 things, right? It talks about the hydrogen, and it talks about the lithium. 2 plus. They both have only 1 electron, right? Lithium has 3, lose 2 electrons, there's 1 left. So both are monoelectronic species, and the only way you can find out, first of all, the energy of one of them, and then to compare their energies is to calculate them. Yes? Okay, so the first one is going to be energy E1 for hydrogen, or we can say for hydrogen, right? Here is hydrogen. E for hydrogen is going to be, well, no, because that H will confuse us. So let's say 1. Let's say 1 for hydrogen. Okay, E1 will be minus RH. And hydrogen has atomic number 1, so it's going to be 1 square. And then it's talking about what kind of first orbit. First orbit. Right? Bohr's model, remember? 1, 2, 3, same thing, like first quantum number, same thing. The Bohr model has orbits, 1, 2, 3, and the quantum model has shells, n is equal to 1, 2, 3. Same thing, exactly. So that would be what? 1 squared. So that would be minus RH. Okay, then, what am I talking about? This should be 1 because it really denotes the number of the orbit, right? So why did they say that, H or whatever, right? It has to be 1. Okay, here, again, it's first orbit, right? So n is equal to 1, so we'll put 1 there. Is equal to minus RH. And then you have the atomic number of lithium is how much? 3. So it's going to be 3 squared divided by the first orbit, n is equal to 1, like there, square. So that will give you minus 9RH. So these are the energies of the electrons for each of these two species. Now, the problem is asking you to find out how much is for the lithium, yes? And you have to do the calculations on here, and it's not really that hard because you know RH from the back of your exam, and that is 2.179 times 10 to minus 18, an extremely small number in joules. And if you do the calculations, then you will find out that it is minus 1.96 times 10 to minus 17 joules. Okay? Well, the problem now is that we have two things to do. So by knowing this and going here, you don't know the answer yet because you have another part of to answer. So if you don't answer the second part correct, then you lose the problem. So it's kind of challenging a little bit, right? So now that you know how you do the first part, it's minus 1.6 10 to minus 17. That's any of these are possible, right? D and E are both possible now because they have the same answer. But which is equal to, which is 9 times, oh, that's easy actually. No, because there is another one there too, which is 9 times lower, 9 times higher. Well, we know it's not equal, right? You can see that they're not equal, right? So E goes away, even though this is correct. So the only things that we have to really decide is between D and A. So is it 9 times higher or lower? Because the minus, oh minus, there's minus. We're going to do that minus there. Right? Remember, I want you to get it correct. By convention, we said, here is the nucleus, and here is the electron. When the electron is in the infinite distance, they don't interact with each other, the energy is the highest, but by convention equal to 0. Numbers. Yes? The numbers mean nothing. Everything is relative in this world. We are in infinity. Everything is infinity. Time and space is infinite. There is no end to it. Which means whatever we talk is relative. Nothing is absolute except one thing. That. THAT. That's the name of it. Everything else is relative. When you say temperature of water is 0 degrees Celsius, and the other water is plus 5 degrees Celsius, what does that mean? When it's 0 degrees Celsius, we have no movement of the waters at all, it's 0. Temperature is the average motion of water, of the particles, right? That's what the definition we gave. We gave the definition of temperature that it denotes the average movement of the particles. So when you say 0 degrees Celsius, what does that mean? That the molecules are frozen, they don't move at all? Of course they do. You better believe they do. So it's a relative thing. 0 degrees Celsius means they're moving less vigorous than what they move when they are at 90 degrees Celsius. When there is ice and it's -6 degrees Celsius or -50 degrees Celsius ice, then it means that now the particles move less vigorous, vibrating, than when it's -5 degrees Celsius. You say it's all relative. Yes? The same thing about distance. You say, my altitude is 1 mile. Well, what's a reference? What's a reference? Sea level? Great. I know where you are. Now, if your reference point is a mine under the surface of the earth, in a mine, inside the mine, and that's the reference point, then your altitude is going to be a different number. Yes? Same thing, if my reference is the top of the Himalaya, right? Then, if I'm in the Himalaya, then you say my altitude is 0. It's all relative. I'm so many feet. What do you mean? Let me see how tall you are. That has no meaning unless you're telling me how long a foot is. Otherwise, I have no idea how long I am. You see? This is a very great concept. That's why this kind of idea is very important for everything. When we judge other people, compare other people, compare ourselves with other people, all kinds of things, it's all relative. The example your teacher gave you before, one student says this about his teaching assistant, and the other student says the opposite of his teaching assistant. That's totally insane. We need to understand, we do not know reality unless we know first ourselves, which is that, T-H-A-T. Otherwise, everything is confusing, and everything is illusion. So, nucleus, electron, right? The highest energy when it's in infinite distance. That's the highest potential energy. Yes. And the lowest is when it's together. Yes? And by convention, we say it's 0 when it's all the way down there. And the more negative it is, the lowest energy. The more minus it will be, -5, -10, -30 joules, whatever. It will be less energy of the system and the electron. Yes? Everybody got that? Yeah. So now what's the answer then? See how many people get it right. If you understood now, you should get the answer. So what's the answer now? Beautiful. How many people got it right? Raise your hands. Okay, good. How many people did not get it? Raise your hands. So I don't understand it. I thought I was really such a smart guy or girl, and I don't want to say that I'm not smart. Come on, you guys, break that ice. Let that little child grow up. And that little child wakes up. Okay? We're here to learn, not to just be shy. What other people will think. Okay? So how many people did not get it right? Lift your hands. Okay, at the end you will come in here, I'll explain to you, okay? No, we'll do it next. Okay, let's go to the next one. That's 11, huh? That doesn't take much time to do, right? You have to write a little bit down, did you? No? You could do it? Okay. Some people can do it by just looking at it. Why you can't do it by just looking at it? Why you don't have to write? Because we're not the same. Look at these fingers, they're not the same, are they? You are better on something else. You probably know how to play music, and that guy who can do it by just looking, he cannot play music like you. Or you can write poems, and that person cannot write poems. Each one of us has something that other people don't have. That's why we don't have to be jealous or comparing. Huh? Is that true? So A, B, C, D. So most people say it's C, but not many. So let's see. Yeah, you're right, but how many people cannot do it? Let me see your hands. How many people want me to do it? Let me see your hands. Okay. Save some paper. Did you bother that you see this thing? Huh? That's just right here, right? You don't bother by that. You save some paper that way, some trees, maybe. Okay, well, what do we have? We have 0.20 moles per liter of what? Of sodium chloride. Yes? I want to find out concentration of cations. So, from that one, what's the cations? Sodium plus, right? When it dissolves. So, what's the concentration then from here of the sodium plus cation? That's the concentration. Look, this is one formula unit, right? One formula unit has one ion. The ratio of particles is also a ratio of moles. So 1 mole of this will have how many? It will give you how many moles of sodium plus? 1. When you have 5 of this, how many moles of sodium plus you will get? 5. When you have 0.2, how many moles of sodium plus you will get? Okay, so it's going to be 0.20 moles per liter. Yes? So it's going to be like this. Everybody got this? So you have so many moles of sodium plus per liter. Remember, this thing tells us that the solution, the aqueous solution is so much molarity in sodium chloride and so much in this. So already these salts, they are in one place, one solution. We didn't mix things. So if you get a liter of this solution, just a liter, that has 0.20 moles of sodium chloride formula units and 0.20 moles of potassium carbonate units in that liter. Yes? In the same liter, correct? Okay. You understand that? We didn't mix solutions. They're already both together there originally. Yes? Okay, now we'll go to the other one. The same way we do it then, you know how it's going to happen, right? So we have 0.20 amps of potassium carbonate, right? And that will give you how many? That's potassium. Now, how many potassium moles per liter? .40, right? 0.40 potassium plus. You agree with that? Yeah. Okay. Now, look. These are in the same solution. So you have 0.20 moles cations per liter, sodium plus, and then you have 0.40 moles of cations per the same liter, in the same liter. So per liter then, the total will be, right? So the answer should be then, if you add them, it will be 0.60 moles per liter, what? Cations. You agree with that? Now, the problem could be a little bit different. So if the problem was like this, let's say the problem was like this. You mix two solutions. You mix two solutions. Like this. What's the answer? Now, they are not together originally. They have two solutions, you're mixing them, and now the question is, what's the concentration of the cation? What's the answer? Anybody? Say it loud, if you know. Or maybe you are...
1.6.
Huh? Or maybe too shy or too humble and don't say. How much? 0.3. Yes? How many people understand it? How many people want me to do it? Raise your hands. Look, you guys. You got 1 liter of 0.2 moles per liter. So in this liter, how many moles of sodium plus do you have? 0.2. Yes? How many moles of potassium cations do you have in these liters? 0.4. Yes? Now you mix them and you have how many moles of cations? 0.6. In how many liters? All right, so it's 0.6 per 2 liters, and for 1 it will be what? 0.3. All right? Okay. Now we're going to take a break. Rudy, are you ready to sing like a bird? Or you lost your voice because you're worrying about your exam? Huh? So you want the, let me put for them the reminder that I want you to remember always, okay? It's coming up. Are you ready for it? Okay, it's coming. Let me find it first. I have to find it first. Maybe surprise you, huh? Oh, you know what? Want to go? Here. Oh, in the meantime, I'll find it.
Oh my goodness.
Got to find what you love. I had no idea what I wanted to do with my life, and no idea how college was going to help me figure it out. And here I was, spending all the money my parents had saved their entire life. You have to trust in something, your gut, destiny, life, karma, whatever. Because believing that the dots will connect down the road will give you the confidence to follow your heart, even when it leads you off the well-worn path. And that will make all the difference. My second story is about love and loss. I found what I loved to do, and then I got fired. I really didn't know what to do for a few months, but something slowly began to dawn on me. I still loved what I did. The turn of events at Apple had not changed that one bit. I'd been rejected, but I was still in love. And so I decided to start over. I didn't see it then, but it turned out that getting fired from Apple was the best thing that could have ever happened to me. The heaviness of being successful was replaced by the lightness of being a beginner again, less sure about everything. It freed me to enter one of the most creative periods of my life. Sometimes life's going to hit you in the head with a brick. Don't lose faith. I'm convinced that the only thing that kept me going was that I loved what I did. You've got to find what you love. Your work is going to fill a large part of your life, and the only way to be truly satisfied is to do what you believe is great work. And the only way to do great work is to love what you do. If you haven't found it yet, keep looking and don't settle. As with all matters of the heart, you'll know when you find it. And like any great relationship, it just gets better and better as the years roll on. So keep looking, don't settle. My third story is about death. The past 33 years, I've looked in the mirror every morning and asked myself, if today were the last day of my life, would I want to do what I am about to do today? And whenever the answer has been no for too many days in a row, I know I need to change something. Remembering that I'll be dead soon is the most important tool I've ever encountered to help me make the big choices in life. Because almost everything, all external expectations, all pride, all fear of embarrassment or failure, these things just fall away in the face of death, leaving only what is truly important. Remembering that you are going to die is the best way I know to avoid the trap of thinking you have something to lose. You are already naked. There is no reason not to follow your heart. No one wants to die. Even people who want to go to heaven don't want to die to get there. Sorry to be so dramatic, but it's quite true. Your time is limited, so don't waste it living someone else's life. Don't be trapped by dogma, which is living with the results of other people's thinking. Don't let the noise of others' opinions drown out your own inner voice. And most important, have the courage to follow your heart and intuition. They somehow already know what you truly want to become. Everything else is secondary. Always wish that for myself. And now, as you graduate to begin anew, I wish that for you. Stay hungry, stay foolish. Thank you all very much.
You guys hear the guitar?
Okay.
And since I might die at any time, I'll just sing the song right
Listening to the song we used to sing in the car. Do you remember Butterfly? Early summer, it's playing on repeat, just like when we would meet. Like when we would stripped and polished, I'm new, I'm fresh, I'm feeling so ambitious, you and me, flesh to flesh, kiss every breath that you will take, when you're sitting next to me, we'll bring life into deepest hopes. What's your fantasy? What's yours? I was born tell you I love you, and I am torn to do what I have to make you mine. Stay with me. down.